Right. Yeah, thank you very much for the invitation. I will present something a little bit different. This will not be a scientific presentation. This will be a path that we've gone through in the last couple of years, in the last 4 years to be precise. And this is a presentation about our attempt. I would say it's quite a successful one to commercialize something in the water sector that we have developed in the scientific sector. So I'm MarTe Zolotarjovs. I'm a leading researcher at the Institute of Solid State Physics, and I'm the head of optical materials laboratory. I usually, in my day-to-day basis, and in the last 13 years that I worked in the institute, I work with nanomaterials. I work with the preparation and more like scientific research. But this is a rare case that we have the ability to commercialize something. And I would like to share some experience of how it went and what went wrong and good or bad and what someone should do or shouldn't. The structure of the presentation is very simple, but the first thing I would like to say is that this presentation is not an advice. Don't do everything that we are doing in the same way, because I believe that for every startup and every company that wants to acquire public funding or private funding or VC funding or whatever it is, the path will be very different. And also, I would like to say that for the Spectromarine, the whole company, the close ties with the academia and the research institutions are very crucial, and that's why I think that it's very relevant. I would also say that this presentation will cover the one of the hardest and yeah, sure.
So we need to kind of because you're also translating it.
I see. Okay, then I'll close the mic.
You'll see as well.
Okay. Yeah. All right. So there are many different ways to how to commercialize scientific results. I guess everyone is very familiar with a couple of those. Is patenting and selling, licensing patents. I would much rather sell a patent or license it from the institute than do whatever we've done here. The same. So let's move forward. Right. Let's just look at the problem of water analysis as a whole. If someone wants to analyze water and determine the quality somewhere in any way, there are many different possibilities. Most popular one is just taking the sample and bringing it to the lab. We have many of those in our country that they will perform for a very low amount of money. A lot of measurements. However, the issue is that you have to bring the sample inside of the lab and you have to manage the samples, and you will lose frequency. But there are a couple of solutions, even drones and all the satellite imaging is very popular, where you can acquire a lot of data with much bigger frequency and with lower cost. But you will lose data quality, so nothing will compare to the laboratory data. So from the triangle, you have to always choose only two, either your data quality and data frequency, or other variants. And that's what we try to solve with Spectromarine. It all started with our pursuit and day-to-day job of creating scientific setups. Once we have the ability to create a scientific setup that can be applied in field, so at TRL 5 level, this basically the whole concept for it. But we deliberately chose only the technologies that can be as low maintenance as possible. So from all the different methods of analyzing water, from the like manual sampling from the pH sticks and all the super expensive 100,000 euro sensors that use electrochemical analysis and everything else, we chose only the methods that can be used unattended for many months. And this is the idea. So Spectromarine is a metal box. You see it on top. It has a lot of electronics inside and optical systems, and also a computational unit. It is a fully automated unit that you put the whole box inside of the water. You connect it to the internet directly with the RJ45 connector. So it's like your router or web camera or anything like that. It connects to our databases and does the data analysis by itself, and you get the dashboard with data that's relevant to you. Of course, the frequency can be as big as you want, up to 1 Hz. We haven't found anyone that wants this type of frequency for any even industrial process, but I guess we'll look for whatever, and we'll look at someone that will challenge us to the speed. But it will generate quite a lot of data by itself, even at like 10 measurements per minute. What it can measure, we mainly focus on the optical system. So we measure everything that has fluorescence or absorption in the UV visible and some of the infrared range. So chlorophyll, thicocyanin, biological substances, all the bacteria that has fluorescence, be it pink phosphor-eating bacteria or chlorophyll, green, blue, whatever it is. Of course, it can measure dissolved organic matter, so everything that's connected with decomposed bacteria or something that, like the algae that didn't survive. It can measure some metal oxides, because you can see that if your water is contaminated with iron, it will be more brown. It can detect that. It also has quite a strong UV irradiation, so it has the ability to measure hydrocarbons, so fragments of oils and fuels and everything else inside of the water. And how does it work? It's quite simple, actually. This is the approximate excitation emission matrix for the chlorophyll on your screen. And this is typically what you get if you want to measure fluorescence for the chlorophyll inside of the lab. So we have tunable light source and full spectrum measurement. And through measuring the spectrum with different excitation wavelengths, you acquire something like this, and it corresponds to different biological matter and processes inside of the bacteria. Typical sensors, fluorescence sensors, you can go to Aleksejs right now and buy one for like $10. They usually use only one single excitation wavelength and one single measurement value. Some of the systems use a couple of the excitation wavelengths and a couple of measurement values, but still it's a point measurement. And then you correlate these points to whatever you need to, like the chlorophyll or whatever it is. The issue with that approach and why those sensors are not frequently used for the very important industrial processes that this signal can be very much affected by other parameters like sun or dissolved organic matter background or anything else, and you will get false reading quite often. And what Spectromarine does, what we have developed, we put a actual spectrometer inside of the box. So we still do multiple excitation wavelengths, but we measure full spectrum. So across the whole measurement range, we acquire quite a lot of data points. I think it's somewhere around 500 data points for each spectrum. And we then perform quite an extensive analysis and peak fitting. It's mostly peak fitting, but right now we are transitioning to more a database-based approach, because we are approaching the amount of data that will allow us to do so. And then we analyze the data set as a whole. So we use different excitation wavelengths. We acquire a bunch of spectra. We acquire also data on temperature, salinity, and pressure. And then we do correlation with some calibration. We also developed our own calibration procedures, because this is a nightmare to calibrate. This goes really bad, but if you solve it correctly, and we have a procedure for that, then it gets you quite an impressive amount of the results, right? And then, of course, we get the sensors, we connect it to the internet, it's all powered, and it sends the data instantly every second. Not every second, it's every couple of minutes to our server. Then we do analysis on it, comparison with different databases, calibration procedures, and then we present the user with the graphical user interface. Or most often, no one wants to see this amount of data. They use it for the automation purposes for their processes. So we developed the system inside of one of the publicly funded projects, and then we thought that what we would do with it, like whoever needs it, or should we even spend our time to massive amount of time to commercialize it. And the first issue is that you have to find a client, right? You have to find something that will catch this idea and put it to good use. So we got quite a bit of a list of processes that you have to follow if you want to commercialize something. For us, the first question was the money directly correlated to the water quality? For example, environmental studies is not a sustainable business model because in environmental studies, if anything happens to water quality, it just happens and it's bad for the people and people will care, but it will not affect the main value proposition for a business, right? Is there a way to control water quality based on data? If there are many processes where water quality can affect the business itself, but it's not correlatable to anything, so we cannot do anything with it. Couple of examples are fish industry in the coasts of Spain, for example. They got contaminated with pollution quite extensively, and they just moved everything to Peru. So they just didn't have the ability to solve anything. Can the pollutant be measured with the device? Let's be real here. This device doesn't measure anything and everything. It measures only specific parameters, only things that we can correlate to. And it's quite an extensive list of things compared to other systems, but we got very often asked like the questions if we can measure, for example, I don't know, uranium concentration in water. We can't do that, right? We can measure only things that are at fluorescence or absorption. We are looking for places where the conventional sensors fail, and we have to solve an expensive issue. So the sensor is not a cheap thing. We have to get money from the business, right? So we have to solve an issue that's substantially more expensive than the sensor itself. So it's much more easier for them to buy the sensor. If you don't find a fit, you will die. In any business, you will just for it's not only water sector, it's anything else. And we of course looked at the fisheries, water treatment sector, where they have direct correlation to all of those parameters, fish farming, and farming in general in water, like shrimp farming and anything else. Desalination, HVAC industries, and everything else. We looked at it, and we decided to start with fisheries. During the first project that we developed this device from, we connected with Pescanova. Pescanova is the largest shrimp manufacturer in the world. I think that there is a 30% chance that if you buy a shrimp in your supermarket, it comes from this company. So they produce insane amount of shrimp. They have like thousands of staff, and they have. It was very funny to visit their R&D institution because it was bigger than my institute, just for this shrimp. So we sent the sensor, we pitched them. They are always looking for those types of things, and we pitched them. They said, send the sensor in. We tried the sensor, we developed anything that we could in the institute. We tried our best to do it, and we got approximately 2 weeks of usable data throughout the whole year, because the system was actually trashed. So it was so bad, it was insane. It failed in every possible way. Every component that we had, except for the window itself, broke. So we decided that we have to take a break from this approach because we will lose this contract, because you have to make them. You can make mistake only once. If you twice make everything wrong, they will not talk to you again. But we got quite lucky because another industry contacted us. They found us through one of the platforms that we were active from, and they contacted us and proposed another case for the sensor use. And the another case is the salination industry. We are quite lucky here in our region that we have fresh water everywhere, and it's quite cheap. But for the Middle East and for MENA countries, it's for Saudi Arabia, for example, every liter of water you get that's fresh comes from the desalination factory. So it somehow went from the sea through the desalination factory and to your tap water. So the industry is crazy huge. And they contacted us. They very quickly determined what the problem is that we can solve. And the problem is membrane biopolymers. So most of the desalination plants, or I would say above 90%, use reverse osmosis and membrane filtering for the water. So the idea is quite simple. You just get this membrane filter, and you put water with a massive amount of pressure through it to get the salt out, and then you get brine and clean water. And the main parameter that damages those filters is biological matter. So if the bacteria goes inside of it, it starts to grow in it, starts to biofoul and kills the filter, and this is a very expensive problem. And this is an expensive problem not only because you will have to pay 100,000 for a new filter, but because you will have to pay for the electricity for the increased pressure of the pump that you will have to push through the water, and you will have to stop everything to replace the filter. It's quite an expensive problem for them to solve, and the idea is very simple. Just put the sensor before the membrane filter, directly before it, but after the pre-filtration. Pre-filtration, in their case, if you want to create millions of cubic meters of water, is basically filtration with a lot of chlorination in it. So it's chlorine, and that's how they kill bacteria. We put our sensor after the pre-filtration, before the membrane filters, and try to determine where the biological matter starts to go inside of the filter. So when it fails, right? And this resulted in quite a successful cooperation. We are currently have 2 pilots running inside of the Saudi Arabia, in one of the biggest plants inside of the Arabia. But we just this year transitioned from the test plant to the operational plant. So it goes to trial 7 now. And through this successful collaboration, we got the insight that this whole business thing might actually work, and we might want to pursue it further. For the timeline of the company and the whole process is it looks approximately like this. So we started with the LEA project. It was mission C 2030, and it was in 2022. It was a 1-year project. It was quite rapid because it was just the timeline was very short. We developed first prototype that year and tested it this area with the fish industry, and happened the same year. And we of course tried to do a patent on the technology, and it was submitted through the institute, so no company was existing there. We continued with Saudi Arabia tests in 2024, and at 2025 was the year that the breakthrough year that we decided that if it doesn't work out, it doesn't work out. Let's move forward. But we were, I wouldn't say lucky, but we were fortunate enough to get an pre-seed investment from the Netherlands, from the NOM. So we got the pre-seed money from a Netherlands fund that is partly operated by private individuals and partly operated by the government. So they have a huge scouting procedure, and they scouted us, I guess, and gave us the money to continue forward and to pursue the idea that we can commercialize it successfully. And in August last year, we established the company in the Netherlands. In that, for both of the couple of words, and then the next part of the presentation will be just the insight that we went through. Again, take it with a grain of salt. You don't have to relive it if you want to do something. And I completely understand anyone that doesn't want to do something like this. But intellectual, let's quickly go through a couple of insights from the business, right? Intellectual property. We got quite a bit of patents in the pipeline right now, but when you start in the academia, you have to always remember that the patents are very expensive if they are not needed. So if you want to submit a patent, and you have to clearly understand what will happen with the patent later on. Of course, there are a couple of programs with public funding right now that require the submission of patent as a deliverable. Just submit Latvian patent, the cheapest one, and forget about it in 2 years. Just do it. But if you see a proposition of value for business that can be acquired and costs money and saves money for them, you absolutely should patent things, right? And it will be quite a bit more interesting for the investor if they see a patent and value outside of your idea or concept. This what helped us a lot. Of course, patent only necessary part. For the Spectromarine part, I would say only 20% of the IP is patented, everything else is closed source. So this is just the state of things. Funding and business strategy, the lessons that we have learned throughout this journey is that if you can use public funding, use cooperation with industry and, cooperation with institutions and with industry, submit projects, biopods, via Horizons, Eurostars, whatever it is, whatever your ambition is. Public money is very sweet, but the investors usually will ignore it. The in-house advantage, if you're developing something that's hardware related, that's at low TRL, tier 2 or 3, that you probably want to keep everything in-house. So don't outsource anything that you don't need to outsource. We did this mistake. We outsourced a couple of parts, but the lead times usually is what destroy the progress and iteration. Constant client validation is a must for any startup. If there is no one to tell you that they need something, it's not because they don't understand, but it's because they don't need it. So you have to find something and problem that you can solve, and not look at your solution and find a problem that can be solved with this screwdriver or whatever it is. And business people, I'm quite far away from business talk at the level that the venture capitals and everyone else is talking to, because I'm a scientist. I frankly am not very interested in those. That's why business people are, if you want to commercialize something and you're a scientist, please employ a business person. It's a very different beast. And I wouldn't suggest any scientist to do business talks to his clients, right? You have to have the right team. For the investors, we have a team of 3 people, 3 core members for the whole company, and we've got the impression from the investors that it's like at the limit. If you have some more people in the company, you have to have very, very good justification why they are there. So don't take your whole project and move to the company. It's not a good strategy. What helps Spectromarine through all the journey is that we accidentally proposed value that we were too blind to see, because we are scientists and we developed a cool technology that can measure spectra and sense the data, whatever it does with the different algorithms and everything else. And the thing that clients mostly cared about is that it's just connectable to the internet, because they operate with the premise from other sensor manufacturers that if you buy a sensor, you have to buy a data logger, you have to have an engineer that will connect everything and do whatever it is, your proprietary dashboard that you will have to connect with some API, or it's a mess. And you will have to pay every step of the way. And for us, the main value proposition, it's not the main value proposition, the data is still the main one, but the big value proposition is from the fact that for the client, it just takes out of the box and puts it in the network and just opens the phone. That's it. This is quite a good realization. It's not connected with the core technology, but it's good to have. Close ties to academia helped us a lot. I covered it already. Work with the institute. They are very much interested in spin-offs and commercialization of Compensate of some sort, because institutions will show you to everyone that wants on the fence about giving the institution money, because they will show that we have some business and value here. So the institutions and the academia as a whole is a good also source of brains. The students, when they are graduating, they are usually the smartest part of the life. They don't want to expand their knowledge. This is the best time to get them. Very rapid iterations. Again, keeping everything in house helped a lot through the whole process. Through the 4 years of development, we've developed. I think this is the 9th version that we are deploying right now, and the 10th version will, by the way, will be made from the polyethylene, not the aluminum. this time because aluminum, if you want to deploy something with Black Sea, aluminum will be eaten away, especially if you have electronics inside of it. Yeah, so 10 iterations of the devices in 4 years is quite a lot. Oh, it's, yeah, 8 generations. So, but the 10 is in the work right now. Good balance between all parts to make it happen. Yes, the early employment of early connection with business people that can push the technology to clients gave us the opportunity to see the motivation first and get the proper deadlines. Because for any hardware startup, it's very easy to lose yourself in deadlines and just forget about what you were doing and fiddle with electronics for 2 years. It will not happen if you have a Zoom call in 2 weeks with potential client that wants the device in April, right? You have to have proper strict deadlines. And again, this also means that if you develop a product, then you have a direct eye to look at it and validate it through the real case, right? Networking is key. It's just, I would say, from the hours we spend on the business itself, I would say at least 30% is networking. Just talking with people, talking with companies, validating, signing all the paperwork, going to the Netherlands to some convention or sending sensors to Saudi Arabia, solving logistical issues, looking at shrimp in Spain, proposing a collagen Euro project with Portugal that we also participated in, sending sensors to USA just to know that OSHA will not allow UV sources inside of public waters to get it shipped back. We were working on that this year. Norway, where we got our first clients that paid actual money for the device. Baltics with the Interact project that is currently running, and we will also develop 6 of the sensors to be deployed in public beaches in Latvia and Lithuania. Singapore for the HVAC industry, Germany with the couple of 2 sensors currently operating in post-mining operations. So they just collect mine water and analyze it. Poland with buoy manufacturing that can do very good buoys, but want better sensor. And if you have something of value, you have to be where the most movement is. And for the Europe, if you want to work in water sector, Leeuwarden is the place to be. It's basically a water hub. It's like a Silicon Valley for water technologies. In Europe, there are quite a lot of companies there that have valuations of hundreds of millions of euros that just do water stuff. We are established there. We were invited there by the Netherlands, the NOM itself. And also, if you want some contacts for the idea validation, feel free to reach out. We share contacts very freely. If you have some idea to validate with someone you want, feel free. We have quite a lot of contacts that can actually help you to get to know the industry better. Let's do no mistakes. First mistake, if you have decided that your tech is TRL 6, you can tell it to the clients that this is TRL 6 and even do free pilot. So you pre-device to someone and say that this is a lab example. This is like rough. This is TRL 6, right? He will say yes. 2 weeks will pass and he will forget about it. He will think that this is a product and it doesn't work immediately. So this happens to us a lot. If you want to like move something through the business structure, the person you will probably get in contact with is the R&D department person that understands what TRL 6 is. But as soon as you send the first invoice, as soon as you try to do a pilot or anything else, they will forget about the TRL part entirely. So they will think that this is a product. Not taking system testing seriously enough, we have twice now sent a device that failed in the first week. I don't know how this happens. It just happens. We are taking it quite seriously right now. So all the prediction modeling, all the calculations, scientific stuff simulations or good engineering, seeking for advice will help a lot. So it's a crucial part. So not to just make mistakes with the shipping of the devices that don't work. We have the device that was working for 3 months inside of the lab correctly, perfectly. We shipped it, but we failed because in the shipping they moved it wrong, right? They were crazy. Feature creep a lot. Yes, it's very easy for hardware startups, and I don't suggest anyone to do so. Is to feature creep, meaning that when you when you propose your technology for a client, he will usually say, "Can it also do X?" And don't try to implement this X in your device every time that you are asked for it, right? If you do, you will get the device that has many different features, and it's very sad for you to fail a device just because a feature that was not requested by this particular client failed, right? So we don't do that. Just have a strategy, work. If it start to do it, if it doesn't work, just scrap the strategy, change it. Yeah. The team, 3 people, myself as a chief operating officer of the company. I also am responsible for the scientific part of the whole operation. Get Zolotarjovs, a wizard was the emails. So he sends 150 emails per day easy. He books, he looks at my calendar, decides where I have free time, books a meeting with some person, briefs through before it, collect all the different contacts. He has a CRM. Does anyone know what CRM is? It's yes. He has a whole system just for the emails. He has like the lists of contacts and everything else just to follow through with everyone. And that is 2 man's extremely smart guy, extremely antisocial guy. So he will never do a presentation about the whole thing, but he can write you, and he can deploy an SQL, fully deployed SQL database like in 1 day, if you want to do it. Crazy smart guy, please respect for him, but you have to have the whole selection of those people, right? Yeah, thank you very much. This is the text, and we are always open to collaborate in the Horizon Europe or any other project as the institute. I'm still affiliated with the institute. I work half my time there, and with more investment, I guess we'll transition to a bit more, but I don't think that I will ever lead science in my life. Thus, if you want to submit Horizon Europe project with us, if you want microscopy data or some crazy scientific setup that we have at the institute, feel free to reach out. And also feel free to reach out if you want to submit some project with the SME. So the Spectromarine is SME in the Netherlands, which can also provide quite a bit of power submission of the project. Thank you.
Well, thanks. Personal many stuff like give us about the 50 notes.
Now it goes to comments that I worry support your strategy events like I have a website as from the business perspective that we must always build those your support systems or ecosystems around you to validate your ideas, and that is the tool to success. Otherwise you're alone in all that pool of revenues ideas, but if you have some partners by us as your aims to move that forward.
Absolutely, the validation from the companies is huge. If it's very hard to grasp as a scientist, because you usually assume that if they say no, that you haven't explained something right, or they didn't understand something, but they did understand. That's don't want it, right? Or want it. I don't know.
But with it, really down on what's going to probably like the wall to get to switch that stuff and you will start with a third figure, the odd horse list that you went to, right? You know, they're out that real balls like
we prove it here. So this is the point. Like I think that the Latvia and Baltics in general, with different varying success, is a great place to build something like this. Just because of a single fact that since we are not a lot of people, we help each other quite a bit. And from my experience with building business in Germany, for example, in Germany, if you want to build a business, it has to be a business. For us, you have much more leeway to make mistakes or get results. For example, if it's also in science, it's the same. In business, it's quite a bit different, but in science, the same story. But if I want to, for example, acquire a SEM image of a very particular material that I want to employ in the device, in Germany, I will absolutely have to pay a lot of money for it and wait for a couple of weeks. Here, I know a guy that knows a guy that can get my sample inside of the microscope today, right? It's just an extreme case of it, but for any other operation, I haven't seen anyone that looked at the Spectromarine and said, all right, I can help you, but I won't. Everyone helps whatever they can. So this is also the BioFOD program is huge for that. Absolutely apply for the BioFOD calls. It's crazy. You get money just to develop things that you can sell later on. And for other countries, it's not the case. So it is built in Latvia, but it has to transition to the Netherlands to move forward because of the it's not a development anymore; it's a business, right? And if you are an investor and you see a water tech startup, you assume it's from the Netherlands, and if it's not, then it's a red flag, right? But we are still here. Right. We have a obligation to move operations to the Netherlands, business operations to the Netherlands, but the development will stay here for quite a bit.
Actually, question about Baltic marketing skills, like on both users. I fully interested in your product, and maybe another question. Product is sensor or data and technological, because it's like you create a sensor, I'll send in sensor to client and it gives full access to data, or other access data yourself and help with I got three questions. First question about data. We do sell a sensor as a sensor, but the whole idea of Spectromarine that it's a system. So it's not only the sensor. In fact, from the development, like the development of the device of the system, only 40% is the hardware and 60% of the database and data analysis and everything else in software. Thus, we have a business strategy where we sell the device and you can actually draw data from it, and some basic analysis that can be performed on the device. But if you want some advanced data analysis, you will have to pay subscription fee because we will use our video cards for that and the servers, right? So this is the first idea, the first question. Second question, Baltics, there are not a lot of clients that use water as a crucial part of the business. So there are not a lot of fish industry there. We have some on the rivers with the salmon and everything, but there's no business client that can facilitate for the growth of us, right? In Baltics, we focus on public funding and projects where we can apply the device to get data for public use. And the indirect project is one of the examples where we will produce the 6 devices on 6 buoys on 3 different lakes in Latvia, Lithuania, in the border side, and get data completely free to everyone that needs it for the researchers. This is the main idea for the Baltics, and this because the Baltic doesn't fit in the whole structure of the value proposition for the business. And third question, can you remind me, please? So data on Baltics, I think it's fun and things like your that's the
all right. So
the question about pieces with bottles and so if you're a company and we are successful, bottles the one most do, but this is doing by company. So how will you divide or give the shape of questions so but
yeah, excellent question. I think that for the scientific person, it's a quite a different process than is expected for the company. But the thing is that if you create something on the institute or the Ventspils also like this, everything that is created here belongs to this place, right? So if it's created by public funding, it should belong to the public. And if you want to commercialize something and get value from it or get investment, this is a crucial part for the investment to get the patent to the company. So they will not give you an investment if it's based on the patent that belongs to someone else, right? So there is a patent transfer procedure that you have to follow if you want to buy something from the public university, and it's very much the same as the public procurement procedures. So you just go through the open market, and you get the procurement procedure from the institute to everyone else that needs it, and everyone has to compete for the better price. And Spectromarine just competed for the better price and paid for the patent.
Yeah, that seems correct. Yeah. Well, thanks a lot. I think because it was fun,
Oh, sorry about that.
very successful, but I think you can continue talking with.
Sure.
First, yeah, so I have to switch to my talk. Wait a second. One.
Oh, thank you very much.
So
Thank you.
thank you for your participation.
Thank you for the invitation.
Yes, so I think I'll continue right now. Thank you.